Hello, class. Mr. Bean here. AP Physics, homework number 4, vertical motion. And this is simulation number 4, graphing motion problem level 5. It says here you will be presented with a motion time graph describing one-dimensional motion of an object. You are to find two different instantaneous velocities of the object and use them to determine the acceleration of the object. When you are ready to start the problem, go ahead and click and submit. Hit End to submit your results when you're finished. So let's go ahead and click on begin here. And so here we have a curve, position versus time. And we have this curve here. So it looks like that something is speeding up. It's getting faster. So each second is covering greater distance. So it is accelerating, and we're asked to find the velocity at two different times, at t equals 2.7 seconds and time equals 7.1 seconds. And so we have to basically, in order to find the velocity here and here, we have to find the slope of the tangent line. So let's go ahead and let's move the tangent line, and it says 2.7 seconds. Let's go ahead and, so there's 2 seconds. Looks like 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7. All right, so we need to find the slope of the tangent line at this point right here. So let's go ahead and kind of see what that might be here. So we're trying to find 2 points here, and I'm going to use this point right here, which looks like so let me go over here and let's make a pin here. So I'm going to go ahead and let's make a note to ourselves. We'll call this the 2.7 seconds here. We'll go ahead and do that. And so this point right here, I'm going to go ahead and use, it looks like T, or it looks like at, so the Y coordinate, so let's take a look at this point 1 here. The X coordinate looks like it's maybe 0.8. So we'll go ahead and say 0.8 here, right? There's 0.8. And the Y coordinate is going to be 0. So let's go ahead and kind of put a comma here, 0. So that's the first point here. Go ahead and make that a little bit smooth there. And let's try to find another point here where it kind of goes right through the, or through exact coordinates. And boy, my eyes are not very good here. Let's try maybe, let's see. This point right here, I'm going to go ahead and use this point right here. I like this one here. So the Y coordinate is going to be, looks like 20, looks like, okay, this goes by 2. So over here, it's got to be careful, 22, 24. So I'm going to say that this is 20, so the Y coordinate is going to be 28. Okay. So we'll say here the Y coordinate is going to be 28 here. Okay. There's 28, and the X coordinate is going to be 5 seconds. We'll go here, 5 seconds. Okay, so we don't have the slope tool, so we have to go old school way. So I'm going to go ahead and calculate the velocity here. We'll call it velocity 1, right? And let me go ahead and get my calculator out here, and let's calculate the velocity. So the change in Y is going to be 28, right? Divided by, and it's going to be 5 minus 0.8. So it looks like I got 6.67. So 6.67 here, right? Let's do meters per second, meters per second. So that's the velocity, instantaneous velocity at 2.7 seconds. Okay, so now we have to find the velocity at 7.1 seconds. So we'll go ahead and move this all the way up there and click away, and let's see. So we'll go, okay, there's 7 there. There's 7.1. So we have to find the slope of this tangent line. And let me go over here. And over here we'll say this is 7.1 seconds here. Okay, 7.1 seconds. What's the slope of this tangent line? Again, I'm going to try to find 2 points, kind of like exact coordinates. I'm thinking right here. So this looks like 3.9 is my X coordinate here. So we'll go, here is 3 point. So we're kind of estimating here, it doesn't have to be exact. So 3.9 is the first point, 3.9, and it looks like it's going to be 10. Okay, it looks like 10 here. Okay, so there's point 1. Okay, let's try to find another point that's kind of close. I'm going to pick this one right here. I kind of like this point right here. So this is 5.1, 5.2, 5.3, 5.4. 5.4. So we'll go ahead and go in here. Here is 5.4. Okay. I got by a stylist. Okay, so it's 5.4, which is right here, and looks like it's going to be 36. This is 30, 32, 34, 36. 5.4 looks like, yeah, 36. So go ahead and put down here 36, right? 36. All right, so same thing here. We'll call this here velocity 2, okay, the second instantaneous velocity. And so we have to do, so we have to, I think this is 10. Let's make sure this is 10 here. 3.9 and 10. Good. So we'll go ahead and do delta y over delta x here, see what we got. So we have here 36 minus 10, right, divided by 5.4 minus 3.9. Okay, so I got the velocity of 17.3 here. So here is 17.3, right, meters per second. All right, so now we have to find the acceleration, which is delta v, right, change in velocity over the change in velocity over the change in time. Okay, all right, so in this case here, here's our acceleration here. Okay, boy, man, cannot write. Okay, so delta v, okay, so change in velocity. So v2 is going to be, was it 17.3? We'll go and put it here, 17.3 minus, looks like 6.67 over here, right? 6.67. Okay, good. All right. And we're going to, oh man. So time delta t is going to be 7.1 right here. Here's 7.1. Okay. Minus 2.7. Okay, so we need to go ahead and do this situation here. All right, so my acceleration is going to be, let's see what we got. Let's go here. So I'm going to go parentheses 17.3 minus 6.67 close parenthesis divided by, looks like 7.1, 7.1 minus 2.7. Okay, and I got, looks like 2.4. So my acceleration I have here 2.4. If we go to the nearest hundreds, I'll say 2.41 meters per second squared. All right, 2.1. So let's see. Hopefully that will be correct. We'll go end, and we'll go ahead and put down here Thanos. Okay, so there's Thanos. Okay, so velocity at 2.7 was 6.67 meters per second. Velocity at t 7.1 seconds, we got 17.3 meters per second, and we got an acceleration of 2.41. All right, let's see if that's correct here. And whoa, hey, Thanos was correct. All right, so the answers were good. So we'll go ahead and use this as a template to help you solve this problem on your own. Now, a big thing is to make sure on the vertical axis is going by twos. So you want to watch out of the scaling. All right, that's it. Good luck, and may the force be with you.